New reports suggest that the Arctic region is warming twice as fast as the rest of the planet. The fast melting ice is opening up new oil and mineral deposits, which is causing a race to unlock more of the region's wealth. But is it also bringing into sharp focus the threat facing the world's climate? Well, for more, we're joined now by climate change researcher Matthew England. Good morning, Matthew. Thank you for coming on board. It's probably a good point to talk about that in terms of, we are seeing warmer than expected waters around the Arctic region.
Yeah, so it's warming the fastest region of the world. It's warming very rapidly. Actually, it's warming rapidly in line with greenhouse gas projections. So the models of 20 or 30 years ago already forecast that region of the world would warm the fastest. It is doing so, but it's actually outstripping our projections.
So what does that mean in terms of how this affects sea levels around the world?
Yeah, so the Arctic ice itself just floats on the ice and won't raise sea levels, but right next to the Arctic Ocean is this massive slab of ice sitting on land, the Greenland ice sheet. Now in that ice sheet, locked up in that ice sheet, is 7 or so metres of global sea level rise. So, and we're already seeing rapid melting of that ice sheet, and that is raising sea levels already. The projections are that by the end of the century, we could see about 1 metre of sea level rise. We don't expect to see more than 2 metres, but even 1 metre of sea level rise would be devastating for coastal communities. So it's concerning to see that part of the world warming as fast as it is.
And in terms of how this data has been obtained, how are these research findings actually being carried out?
Yeah, so satellite measurements detect very, very accurately the coverage of sea ice. So these are direct measurements from satellites. We can see very clearly from space where it's ice covered and where it's ocean covered, because the ocean's a much darker colour from space than the whiteness of ice. So it's very clear measurements, and the records go back 30, 40 years from the satellites, and then much further than that from direct measurements from expeditions into that part of the world. It is a region that's been heavily monitored because there are lots of fossil fuels, lots of natural gas and oil there, and ironically there's a bit of a excitement amongst the fossil fuel sector, that this region's opening up for extra exploration.
Yeah, that was the question I was wanting to ask you. I mean, obviously with the ice starting to retract from these areas in the north, it's opening up more areas where people seeking minerals are going looking for them and what have you, but in turn that would no doubt lead to more greenhouse gas emissions.
Yeah, it seems to be a problem at the moment. The world is voracious for its appetite for fossil fuels, and every time there is the possibility of some extra fossil fuel reserves being discovered and being accessible, then industry is going in to try to tap into those. And I think that wouldn't be occurring if there was a sense amongst industry that governments internationally were taking the greenhouse gas challenge seriously. So unfortunately, until those companies are given the indication that that industry is drying up, there will be continued strong attempts, massive investment in digging up fossil fuels, and they are the problem that's driving greenhouse gas increases in the atmosphere.
So if we were in fact to see greater generation of fossil fuels and greenhouse gas emissions, could we be expecting even further degradation of the environment and greater warming and related problems?
Yeah, this is an amplifying feedback actually, because you're melting back a slab of sea ice. That's opening up a region for exploration for fossil fuels, and that means we'll tend to have those fossil fuels cheap enough to be burnt instead of going to solar and wind and so on. So it's actually an amplifying feedback where more greenhouse gases will go into the atmosphere unless policies are put in place to limit those growth of greenhouse gases. I should also say the other amplifying feedback there is once you remove the sea ice, that's a very reflective surface, and once you do that, the oceans open up and they absorb heat very readily, and that's another way to amplify the warming. That's to do with the removal of the ice reflectivity by melting it. So there are lots of reasons to be concerned about that region, because it is a region where once this warming occurs, it feeds on itself and exacerbates the scale, and that's why we're seeing quite rapid retreat of the ice.
So what are current projections like for that region given these new findings? So
the projections have the Arctic as ice-free by the end of the century as a worst-case scenario, and like I said at the very start, the observations are looking like that's an underestimate. It looks like by 2030 to 2050 there'll be ice-free seasons in summer over the Arctic, and there's a very strong misconception in the community that the climate models are overstating this problem. In fact, many of the metrics that we look at are running away faster than the model projections are. And I had to actually correct Nick Minchin on this point on ABC Q&A a couple of months back. Again, he put forward this idea that the projections were racing away faster than the actual observations, and that's not true, especially for the Arctic region.
So in terms of where we're at with trying to control this sort of situation, do you have concerns that, you know, we won't be able to keep pace with this?
Yeah, I mean, the only way to control the situation is to bring down our greenhouse gas emissions. There are many ideas around to geoengineer ourselves out of this problem, but all of those are far more costly than just simply going to the technologies that we have available: solar, wind, geothermal, wave, tidal energy. There's a suite of technologies there that are actually advanced enough to solve this problem.